Okay. Hi everyone. So for today's meeting, we want to discuss what are the next steps for the pod level checkpoint restore, and essentially the current state. We received a lot of feedback over the past week or so, and most of the feedback is about the restore functionality, how this would be implemented, and how this, if there are any security concerns. Um, what we currently have in Kubernetes is the checkpointing functionality, checkpointing API for containers. And what we can do today is essentially create a pod YAML spec that allows you to essentially use the container checkpoint to restore a pod, essentially from this container checkpoint. The problem is, how do we simplify this so that users don't have to build OCI images from the tar files of container checkpoints, and how can we combine essentially all the information about a pod that allows us to restore um, essentially the whole pod from a checkpoint. And based on the feedback, we essentially the consensus is that we have to simplify and first focus on proposing these CRI APIs that would essentially allow us to implement the functionality in container runtimes. So in this case, we focus the proposal itself for defining this pod checkpoint pod and restore pod CRI APIs. Then once this is enabled in Kubernetes, we can essentially extend CRI-O and containerd to create a snapshot of a pod. One thing that most people also commented on was that we want to be able to support multiple runtimes or checkpoint restore implementations. So in this case, we have two main examples. The first one is run CC run with CRI-O. This is the default that many people use, and then gvisor is another essentially checkpoint restore implementation. And the main difference between CRI-O and gvisor, well, they work in a different way, but the set of artifacts is different. So CRI-O essentially creates a set of image files that are that represent the container, the state of the container of all processes running in the container. And gvisor essentially creates a single image file that essentially represents the whole state of everything. And I guess our goal is to create a proof of concept that shows the CRI APIs we have defined works with both implementations. And I think this will answer essentially this question, whether we can support more than one implementation. One thing that many people have asked is what is the best way to do to restore pods from a checkpoint? And we discussed this also with Peter earlier this week, and he suggested that maybe one approach could be to define a sub-resource. And I was trying to see what this could look like, and I guess we don't really want to make kubelet level. We won't focus on kubelet level API first, and then to propose API server changes. But it's at this point, it's not clear whether we can do one without the other. But one API that we could perhaps propose is essentially something like this. So we can have restore as a sub-resource for the pods API. And then we can define, for example, parameters like, for example, the snapshot name and, for example, whether how volumes should be handled, and essentially shared resources like GPUs, for example. And this also, I see that Kevin is also here. I'm not sure if he's in the meeting, but yeah, okay. Kevin, I was experimenting with essentially the GPU plugin. So we can checkpoint restore containers with the GPU plugin, but when it comes to essentially checkpoint restore with dynamic resource allocation, I was able to get the checkpoint restore functionality working only when I explicitly specify all the external mounts, mainly because of this commit in CRI-O that essentially requires external mounts to be explicitly specified. And the other thing is the container restores, like it appears to be restored, but the GPU state is still checkpointed. Essentially, when I enter the container with kubectl exec, there's like I can see all the mounts are there, but for some reason the GPU is not initialized or something like this. And I have to investigate further why it happens. But this is how far I got. And I guess one question is how to handle external mounts, because from my understanding from the commit message, if we download a checkpoint, for example, from OCA image, we don't want this checkpoint to essentially use random paths on the host, essentially to mount random paths from the host inside of the container. Do you have any comments on that?
Are you asking me?
Yes, I think you mentioned that we should talk with the working group working on the device management working group, I think.
Sorry, maybe I don't think you have to solve everything like right away. I mean, my comments are more making sure we're thinking through edge cases and testing as early as possible. And so, I mean, if the DRA stuff isn't quite supported, like it's something we can work towards. So that's the step one. I think that DRA is a little challenging because it's going to be a lot of dependent on the device vendor. So I actually don't know the best way to for example, there is the work by Antonio for I forgot the name of it, Net DRA or something, where they're using DRA Net, where they're using it for network devices. And I don't know like if the same, I mean, it sounds like we haven't really figured out networking, and I don't exactly know how the DRA support would work there. So I feel like it might be like each device vendor has to kind of figure out how this works with DRA. So I don't know the best way to suggest going about that right now.
Yeah, I think for networking at the moment, essentially the consensus is to just create a checkpoint by closing the TCP connections. And later on, when we decide to work on migration, we can start investigating how to preserve the IP address and do migration. But Peter, do you have any comments?
Yeah, I mean, DRA net's a little bit different from the normal network namespace, like through and configured through CNI workflow, because there's the resource claim that's attached to the network device. So, like a network device separate from, the network stack for the pod that's set up. But I agree with Kevin that like these are good things to think about and explicitly call out as out of scope, and then we can do follow up once we actually have some minimal viable product on like the things that are within scope. I think something that this working group should consider, and I've begun to think through a little bit and like try to think of what it would take to do this, is actually extend the scope of the existing KEP to include API server awareness of the restore call and the checkpoint call, because of this like problem where like if we expose a kubelet API to restore a pod, but the API server doesn't know about it, like who like is the kubelet just going to run that pod underneath the API server? Is the kubelet going to tell the API server it's existing? Like there's no like path to sort of like notify the API server that this pod suddenly exists. I mean, we could like take a similar approach to static pods, but to me that feels a little too one step forward that we'll have to then like throw away later, because like eventually in a world where the API server is aware of restores, it would probably create the pod object, I guess. I don't know. So I think we need to work through sort of what it would like, what our API for restore actually looks like. The API for Checkpoint, I think, is a little bit clearer, but maybe not. I don't know. So I think we need to like work with API machinery and maybe even SIG architecture and talk through like what their recommendations would be for what this looks like, and then include that within this initial KEP, which will, I think, make the entire KEP consensus process take a little bit longer. But I'm hoping that we can do that if we start that now, and then we like work on talking to the individual SIGs while we're in the enhancements lull between, code freeze. I mean, between now and basically when 136 is released. I'm hoping that we can sort of get a consensus in early 137, even if for the initial alpha, we don't actually include API server awareness. It'll help us pave a path to get there, I think, better than the existing scope of the KEP that we have.
Kevin, do you want to go next?
I was just I'll be honest, I kind of tuned out the KEP a little bit towards the end. What were the main what were the main feedback we had to address for alpha? And like, do we exactly know, because it wasn't as clear to me, and like I didn't see much response after I mean, it sounds like the reviewer bandwidth wasn't there, but I'm like not as clear on like what we need to solve for like alpha phase 1, and maybe that's like helpful to get maybe clarity on, because
the takeaway that I had, basically all of the, I think reviewer bandwidth was a problem, but I think the thing that I got stuck on was our initial approach was say, define the CRI API and then integrate that into the kubelet endpoint, but then stop it there for this KEP. But then Tim Allclair came up with the point, which is this like restore problem, which is like, okay, if we restore the pod within the kubelet, like what is this pod object? Like, where does this pod object go? How do we tell the API server about it? And I didn't really have a good answer for that within the current existing scope of the KEP. So to me, my response to that is, okay, I think we need to expand the scope of the KEP to actually answer that, to have a way to answer that question within it. Even if it's still an iterative process of implementing it, we still need to have an answer of how eventually we're going to do that. So we don't like do work that we have to then undo. So to me, that was the biggest like blocker that like we didn't have a good answer on. There was a moment where I was like, oh, maybe we just introduce the CRI API and then we like work on the other stuff later. But it was a little bit too late within the enhancement season to sort of like get consensus on that direction too. So that part was reviewer bandwidth. But I think the primary blocker was like, because we were trying to subvert the API server, but actually the way that we would have done it would require some amount of API server awareness. It like was confusing and wasn't totally clear what to do.
Yeah, I guess that makes sense. I mean, that's sort of the one thing I'm worried about is the immutability for pods and the fact that there's so much work going on where we're changing like a lot of the pod templates. And I am wondering, like, from what I saw from the original POCs of Checkpoint Restore, we were passing in like an image that was the restore image, which does mean we are expecting to, change the pod information, right? For restore would not be exactly the, or
not,
that...
No, so that was a proof of concept that predates what we could possibly do with a restore. So I think that this is the question that we have to answer. We imagine a world where we have a checkpoint archive. How do we tell the kubelet API server and CRI implementation to restore that? The API for that will sort of dictate how we answer this question. The current approach being like with the old forensic checkpointing, container forensic checkpointing work, it's bundled in an image and then that image is created in a pod. But because we're actually going for like legitimate restore in Kubernetes, whereas before it was sort of like subverting Kubernetes because like we didn't get to the implementation, we can actually do it like in a way that maybe wouldn't change the pod generation or would like require someone create a new pod, or like, you know, we have more options for what this looks like that don't potentially require changing the pod generation, but it might also. So we don't have a concrete answer to that question, but my hope is that doing it in a little more legitimate way will give us space to answer that question more elegantly than we were able to when we were just sort of like hacking it in.
There's one interesting comment in the chat about in-place restore. So I guess in-place restore would mean if you want to restore the pod from a checkpoint without creating a new pod. So something similar to restart, I guess.
Yeah, that's kind of the idea. So basically, we are restoring against a existing pod. So pod object has been already there, and we must guarantee that the snapshot we're going to use are exactly the same, like a runtime spec and the image spec as that pod to be restored in place. So some idea like that.
Do you think, Peter, we should define this as essentially as a use case in the KEP, and then we can describe how it could be implemented?
I'm trying to think of what the use case would actually be. Like, we currently have two uses that we're thinking about for checkpoint restore. We have the live migration, take one check, like, pod, maybe stop it for a little bit and then move it somewhere. And then we have the like cold start, where you have one pod and you're duplicating it a bunch. So we don't.
I can describe it. So, for example, if you have a workload that is running for a long time, like several hours, for example, and for some reason it fails, instead of restarting from the container image from scratch, you can restart from the last checkpoint. So you can use periodic checkpointing to enable fault tolerance. And this could be a training job. For example, if you do machine model training, you can essentially use this as a fault tolerance mechanism.
Yeah, I mean, I think that is definitely a case that we can consider. I think it'll semantically look pretty similar to the live migration, just without maybe a stop. Instead of the kubelet triggering a stop in between, it would be, the process crashing or some other sort of entity. Like the pod would need to be stopped for the single UUID to be maintained, but yeah, that definitely is something that we can consider.
And I think this is the person from Sync Networking, but I don't remember your name. Can you? Sorry. I think you're muted.
Okay, can you hear me? Sorry.
Yes.
Yeah, I have a question, because I think we should make sure that we're not trying to fight like Kubernetes kind of semantics. So as I understand it, like the immutability of pods is like fairly baked, fairly deep into the system. And I wonder, like, talking about, resurrecting a pod, like what is the kind of life cycle that's being recommended? Because if it's way outside kind of like what is currently done with pods, you might have some difficulty integrating into the rest of the controller ecosystem, like deployments and stateful sets and those things. And I think that's where it gets really tricky if you want to create like a new style of lifecycle. Like, those primitives will be hard to reuse.
I think Peter can also talk about this, but my view on this is that we don't want to introduce like a new pod lifecycle. We want to be able to essentially either create a new pod from a checkpoint, or if we live migrate, we want to be able to essentially move a pod from one node to another.
Right. That action does not exist today, right? Like, it's actually a new pod because it's on a different node. I don't even know if it's possible in the API server to create something with the same UID, because that's handed out, in the UID generation process. Like, I think the first one that you're talking about, where you have a new pod and it somehow comes back with the state, that one feels more feasible in my mind.
Yeah, makes sense.
I mean, I think, like, as we're talking through this, we're talking about like a long-term eventual possible end goal. I definitely do agree that there are like open questions on how we do that or whether we can do like the live migration or the in place checkpoint restore. And I think we need to be, I think that is an open question that we don't have a really clear answer for quite yet, because like semantically it is something unprecedented, but also like a lot of this new work is also unprecedented, and the Cube community is moving into at a speed right now that is doing a lot of unprecedented things, like thinking workload aware scheduling and all of the thinking about topology in this sort of like much larger way. So I think like there is space for changing the paradigm a little bit, but we have to like, I do fully agree that like in doing so we have to be very sure that we're like changing it in the correct direction.
Yeah, I would just be careful, because like even from my experience, for example, adding like multiple network interfaces, that was, or even IPv6, like it, quote unquote, a small change, but it took like years. So
yeah, I think I am personally conceiving of this entire effort as a years-long process. And like I can think of no fewer than maybe 4 or 5 KEPs that like all the things we're talking about will involve. And I think a lot of the challenge that we have presented to us is like choosing the set of things that we need, like we can work on and we can agree on, and then iterating on that with additional KEPs built on top over the course of years. But
yeah,
I
think that
totally see what you mean.
I would definitely look for like what is the, because a lot of these things are like evolution, not revolution. So definitely thinking like what is feasible now towards the future is definitely useful.
Mm-hmm.
Vicky, do you want to ask something or say something?
Yeah, so we are talking a lot about architecture and API conventions, and we are sort of circling around it. Shouldn't we maybe like go to the SIG architecture meeting as well, or to SIG API machinery, or invite someone from over there to us? Because like we have these questions and we don't know what would they say. So maybe they have some sort of like standards or some idioms or some design principles that would constrain us, at least in the thinking. So maybe we would like consider correct approach from the beginning to like some of the questions we are talking about, like even about the retaining folio ID, or anything that we are talking about. I don't know if we are able to like suggest something and describe in a KEP without consulting these groups, because then someone from this group will come and they will like tell us, well, this is against the design principles. So
yeah, and I mean that's basically what my suggestion is for the 136 timeframe. Now that we've slipped the KEP deadline, is we spend this time going to all of the other entities that are involved and being like, okay, what do we need to get some MVP in the API server for checkpoint and restore of pods, and then coming up with a design so that in 137 we have a proposal that people have by and large agreed on.
Yeah, makes sense. I think what we usually do is we start with some simple proof of concept, some idea of what we could potentially implement, and then ask for feedback on that during the meeting.
I put some stuff in the chat, but my advice is like what I know SIG architecture will ask you is just like how far can you get without fundamentally changing piece of the ecosystem, right? So if you can answer that question fairly well, then it's easier for them to talk about changing stuff. But if they ask and you're like, well, maybe, I don't know, like then the discussion's like, well, okay, why don't you go try that?
Yeah, makes sense. I think the main challenge is what Peter described. How do we restore a pod without telling the API server? And this is something that we cannot really solve.
Is that something you need to do, though?
No, I don't think. I actually think our current problem is like, what does it mean to duplicate a pod? Like, we have two classes of things. We have the warm start where we're actually duplicate a pod. Sorry. What does it mean to copy an existing pod and run it again? Because the warm start problem I think we can take, like, to answer your question, I think like we could do the warm start problem pretty much now, like without ecosystem, like groundbreaking changes, because we're duplicating an existing pod and creating new instances of it, like a bunch of new instances of it. And that's like very similar to like just creating a bunch of new pods. We're just starting from a different point. The live migration piece of it, the like taking an existing pod, stopping it, or like responding to it stopping and moving it as it existed before somewhere else, that is more fundamental. And I think we would like struggle to do that within the current sort of like idiomatic Kubernetes style of work. And so
there is something to look at, which is stateful set. So stateful set is like ostensibly trying to handle the case where you have like a database like number 3, and you need to it manages the lifecycle of database number 3 along with the persistent volumes or whatever. And like that one has been around a really long time and kind of has this one copy notion, and seems useful to look at that.
Mm-hmm. Kevin, your hand.
Yeah, I guess I'm a little, so like what I understand we were doing at first was forensic checkpoint. There was no API. We kind of ran into problems because we were at the container level. We are sort of getting to the point now where we need to define what does it mean to checkpoint a pod. But then I guess we are looping in the idea of restoring a pod also as our like phase 1 now. And like I'm wondering, like to me it maybe what's helpful is like with the KEP process, like if you can keep your scope as small as possible, things will go a lot better than trying to boil the ocean from like day one. So like, I mean, I'm maybe a little confused on like what really is our goal for, with our KEP for 1.36 and 1.37, I think we all kind of agree we need some API. I think the main concern everyone has, I think, is on restore and the fact that it's actually kind of hard to do. And also, I think there's a lot of security implications of restore that haven't really discussed very much. So like, I feel like this is why it's going to get hard to get this in, because I think we're kind of trying to boil the ocean with this KEP. And
my response to that, though, is like, how useful is a checkpoint without a restore? Like, if we don't have a path to actually use the checkpoint, then we're just like putting stuff on disk and then letting it sit there. And there isn't like in the forensic checkpointing world, we had this hack basically to restore containers by like, having the runtimes take the image name. And if that image name is a checkpointed archive, then it like restores that rather than creating it. But in a pod case, that doesn't work because like we have this whole bundle with the checkpoint, and like what do you point the image name to? And also that comes up with this new pod, version problem. So I don't think we're boiling the ocean. I think that there's a way that we can scope it down to the point where like we try to exclude, stateful workloads. We try to exclude, I think that there's a number of things that we could potentially exclude. We try to not do like network migration to start. Maybe we have to scope it down to just the warm start case and not the live migration case. But I'm feeling like I don't think the KEP, like if we started with if we had this existing KEP only be checkpointing and we got it all the way to GA, I don't think anyone would use it because like checkpointing is not meaningful without restore. So I think we do actually need to answer these questions and like come up with a way to have restore be a sanctified, operation in Kubernetes, even if it's a really hard thing to like come to consensus on, because I don't think a checkpoint is useful without it.
is also something similar to what we did, for example, in Podman. When we introduced checkpoint restore in Podman, it was kind of similar question. Well, we first have to implement the checkpoint functionality, and then once we have the restore working, we can essentially propose the changes upstream, because otherwise we are not able to show that it actually works, the checkpoint restore functionality. Benzan, do you want to say something?
Oh, yes. I want to comment a little bit on the, what we should focus also. I mean, yes, without restore, I mean, the checkpoint is meaningless. And maybe what we can do is we first propose things like including the object to represent the pod snapshot, and to get some official object support. And after that, we can talk about the restore, how it's compatible with all the cases. Maybe that can speed up the CAP approval and the development. We also need to depends on how fast we can get that working. And speaking of the restore case, I mean, I want to echo to Bowie's case. I mean, for the stateful or any high abstract object, it's tricky, right? I mean, for example, like stateful, it has a restore policy, and after we take the checkpoint, what does that mean? Do we mean the pod, the lifecycle terminated? That will break a lot of things, like what Kubernetes do for the stateful set, for the deployment, for everything. I mean, that's a long call. I don't think we should cover that in the very first CAP. That will be, I would say, very, very painful, and will strike down the progress.
Yeah, and I mean, that's what we try to do in 136. I guess I just don't see, I think that it's going to be a big CAP, because I think it's a lot of work. And I would love to find a way to slim down the proposal so that we have a higher likelihood of moving forward. But I don't want to do that to the point where it's like we have a CAP that if it GA'd, it would be not useful for people. I think within the first iteration of the CAP, whatever CAP we work on, once that CAP GAs, it has to be a useful feature. I think in the process of getting it to GA, we can have a bunch of iterations, and we can say okay, alpha 1, just CRI changes. Alpha 2, just checkpointing in the qubit. Alpha 3, we have, checkpointing in the API and restoring in the API. Then we go to beta with that. And then we go to GA with that. I think we have room to iterate, but I don't think that we should scope the CAP all the way down to the point where it doesn't end up being useful. But I'm open. I'm open to discussing that point. But just to me, our original scope of the CAP in 136 was hoping to do that, but then we hit this fundamental problem of actually, if we scoped it down to just be kubelet level changes, the relationship between the API server and the newly restored pod is not clear, and we can't answer that question without actually having an idea of what the API server will think of that pod once it's restored. And so we need to answer these questions now. And so I think we do need to do a certain amount of ocean boiling to get there.
Yeah. So let me try to reword it in my sentence. I mean, let's get the CAPs for the initial proposal and iterate in the middle, and until we feel it's confident to GA with the checkpoint restore and all the changes to the compatibility checks with existing KDAS API server apps like a standard, then let's do something like that.
Yeah, and our first step is basically going to all the relevant SIGs and being hey, how would we do this? Let's try to answer this question now, even if the initial implementation won't actually include that at all, so that we have an answer when as we're designing towards that eventual goal.
Yeah, that sounds reasonable to me. What do you think, Alison?
Yeah, I think it makes sense. Essentially, what the advice that everyone here is giving us is very helpful. And essentially what Peter is summarizing is the next steps that we can follow. I think this is very helpful. And I see also Kevin has his hand.
Yeah, I guess what I'm thinking is that It sounds like we're going to need pod API changes because we can't rely on an image and we don't have any information on the pod level about a checkpoint or a restore.
Yeah, that's what this, like, if you see the kubelet level pod restore without API server changes, that actually is not quite right. I think we need either pod API or a new restore API.
Well, I more mean like, because what it sounds like you're saying, like we want to say, I want to take a snapshot of a pod. So I'm imagining the pod spec all has to change, but somehow the pod spec needs to know that it's actually a restored pod. So I'm wondering if we like really should consider like a new struct in the pod API for like the checkpoint information or checkpoint or restore that kind of allows us to say like, this is a checkpointed pod, but I'm actually going to start from a restore or something. I don't know. Cause like, I don't feel like there's any fields that we can change on the pod spec that will reflect that this is a checkpointed or a restored pod without thinking about the pod API a little bit. And not just like the endpoint, but like the fact that like if we're not, I was going with the fact that we would just override the image like we did with the forensic checkpointing hack that we had. But if we basically want to say this pod spec doesn't really change other than it's being restored, I feel like we're going to need to think a little bit about like the representation of the container, I guess.
I think we're getting a little ahead of ourselves in thinking through exactly how we're going to do it in the pod API, because there are a couple of approaches. We could create a new, like the restore could be an API, checkpointing could be an API, or it could all be nested within the pod API in fields there. I think we need to talk through API machinery and SIG Arch to talk through exactly what the approach is. But I agree that there will be an API change. That we can't like get away with the existing API to reflect all that we want to express. I just don't know where that API change will be, and that's part of our investigation that we need to be doing now. So like an option is including new fields in the pod API, or we could create a whole new API that will then eventually boil down, like, have a new pod object be created. I don't know.
Yeah, I think we can probably work on what options we have in terms of APIs, and then we can discuss which will be the best option.
Yeah, what I'm hearing sounds great to me. Like, I recommend having some high-level approaches and just like, hey, what do you guys think? Is this totally off base, or is this like something that's more reasonable? One thing I've seen in previous proposals is like someone going super deep in one direction, and it turned out that people were like, well, I don't, wait, like we didn't want to go there. So just throwing some high-level things to see what direction people want is really useful.
Yeah,
Yeah,
I think it's a good idea. Yeah. Vicky, do you have any questions? I remember that you were working on scheduling and how this could be integrated, for example, with the eviction API.
I think that is far future at this point. Though I think that regarding the pod API discussion that just happened, I think that like a new pod, either like a condition or a phase, could signify that there has happened something with the state of the pod, because essentially if you checkpoint the pod, it gets into some sort of another state. Like everyone who will use this will want to know what is the state of this pod, and I don't think that current states capture this anyhow. Like maybe we could approximate this in a first round with, let's say, like pending pod, and that might signify that it's not running, and then after restore it could be in a running phase. In case it would be too hard to introduce new phases. But I heard from many people like interested in this feature that one of the first things they ask is like, so what will be the state of the pod? Like, how do I know it was checkpointed or restored, on the first glance. So
I have a question on that. Like, is the pod and then a checkpoint the same thing, or are they two different things? Because you could checkpoint a pod and the pod could still run it. You could checkpoint the pod and ensure that the pod immediately dies. Right?
Well, I
like,
guess it depends on if you like.
Do you need that same object to represent the checkpoint?
Yeah, but we have, I think, two directions with this, and we already discussed this. Like maybe already in the first meeting, we agreed that basically we have two use cases. One is that you will leave pod running after checkpoint, and the other one is that you will stop it. It's
right.
like,
but I'm saying that in your API for Kubernetes, is the checkpoint going to be one-to-one with the pod? It sounds like it's not, right?
Yeah, it's not. The checkpoint is separate so that we can create a new pod from this checkpoint. And this also, if you want to replicate the pod, you can use a single checkpoint to create multiple pods.
So in that case, like, does it make sense for the pod to actually to have it be exposed to that state? You get what I'm saying? Like, does the pod need a I am checkpointed and suspended state?
It's more
because they're actually like decoupled from each other.
Yeah, I think it's more like we need to be, when we create a checkpoint of a pod, it could take like several minutes, depending on how large the state it is. For example, if you have a workload using 4 GPUs, each GPU has 80 gigabytes of memory. Saving all this data to disk takes like a few minutes. And so essentially during this time, the pod is not actually running. Essentially, we need to freeze the pod to create a consistent snapshot. And I think what Vicky was referring to was, how do we let the Kubernetes know that the pod is not running at this point while it is being checkpointed?
But does the pod actually still, for example, like there's like a state that the pods can be in, like with Kubernetes jobs, where it's like finished, right? But the pod object still remains. And it's worth thinking about all that, because you don't want to end up with, like, for example, one of the things that will be a problem is that if the pod is suspended while checkpointing, it will fail all its health checks, right? In which case kubelet will delete it.
What we discussed, I think this was something Peter mentioned, is with containers, usually we have paused state. So the container could be paused. This currently doesn't exist in Kubernetes, but if you want to introduce this new paused, essentially when the pod is in a paused state, it's not suspended, it's not terminated, it's essentially just not consuming any CPU or GPU. Essentially, this is something that we can propose in the future, I guess. But yeah, I think for now we want to keep the
existing.
What I'm saying is, like, from practical matter, like kubelet, will pause mean that kubelet health checks will always return true, for example? Like,
I think the kubelet will have to I think that there will need to be a state of the pod for checkpointing. I'm not sure if we'll have one for checkpointed. I think we have to discuss that, and that'll depend on what the restore API looks like. But checkpointing in the kubelet would mean that it needs to stop doing health checks because it knows that the pod is paused. So it needs to like wait until that's finished, and it shouldn't kill the pod in the middle of the checkpoint happening. And I think that should be reflected in the pod status so that a user can see why their endpoint is suddenly not responding because it's paused. So I think we need, at the very least, a checkpointing status. I think it could be an interesting sort of exercise thinking through what the pod API would look like if we kept it all encapsulated in there. Like if you had a checkpointed, aspect in the field in the pod status, and that pointed to the latest checkpoint or like a series of checkpoints, then a user could, call an update on a pod or something and reference that checkpointed ID to like restore a new version of the pod. Like that would be a little bit weird, but like I think it's worth thinking through that as an option, as one of the multiple ways we could express this in an API. We could also probably get away without a checkpointed status if we have it be entirely checkpoint and restore in new objects.
Yeah, like
the
one question is checkpoint always going to be impactful on the pod, or because there's ways to checkpoint it on the side, right? And the pod keeps running.
Like, I think potentially, but and like especially if we're looking at higher level controller checkpointing where they have like a PyTorch like checkpoint probably might not be as disruptive as like a Cryo one would be. So I think we could think about that. And I think that that could be expressed in the API. But I think to start, at least the two use cases that we have being gvisor and Cryo, I'm pretty sure both of those are disruptive. And at the very least, like I don't think if a pod is being checkpointed and then like crashes or then like changes its state or something, like I think that that moving target could make the like what the checkpoint actually has be kind of confusing. So I think to some degree, I think it should be like an atomic state of the pod. And I think to express that right now, it should be paused. Unless some other checkpointing provider can do it so instantaneously that like there won't be any weird state stuff that happens as the like moving target shifts.
I have one question. So do you remember, Peter, when we discussed essentially the option to create a checkpoint of a pod and then stop the pod, not leaving it continue? And this is where I was considering that the state checkpointed might be useful. And because if you know, instead of terminating the pod, you can essentially leave it in a state where you can essentially resume from the checkpoint. So this is something similar to preemption. I think there are also some comments in the chat, but essentially when you want to suspend, well, use the checkpointing mechanism as preemption.
Yeah, exactly. And yeah, that makes sense, and could be a reason to have it all or like more encapsulated within the pod spec to be able to reflect that.
Yeah, and for the second part, there is something called asynchronous checkpointing. This is not something that we currently implement, but this is something, for example, that PyTorch supports. And this is essentially, it allows you to create a checkpoint while the application is still running. It's more complicated to implement, and it's not something that we can do at the moment, but there's some research projects on that as well.
I also think like a Cryo-based checkpoint, I mean, we need to kind of like freeze, since we need to freeze the C groups, I mean, there's nothing can be wrong there. So it's very hard to create a non-disrupted like a checkpoint or, asynchronous checkpoint. And regarding one of the things that I mentioned by Peter about the, pod status, like a health check, also mentioned by Bobby. I mean, in our experiment, I mean, we built some more pod samples from GKE and we feel like the checkpoint status is necessary for good visibility. But, even like without that, I mean, the pod during that case, since the C groups are freeze, the health check will just time out. And it will like tolerate like by, for example, like the pod, if it's associated with some services, it will be, tolerated there. So, the pod will not be served, but the status, I mean, will keep like showing it's running. And, I think the open source like pod lifecycle is pretty like stable and strong to deal with those cases. But it's always good to have this middle status of the checkpointing to represent that the pod is not available.
Yeah, I think it's something that we should probably clarify later on. Essentially, how to represent this in essentially how to implement this from the container runtime to essentially to reflect the state of the pod from the container runtime to the kubelet. One thing I have as a question is this is also something that someone asked me in the past. Essentially, if there is a way to abort the checkpointing mechanism, like for example, if you have something that takes a long time and you just want to cancel the checkpoint operation, I don't think we have discussed this in the working group, but essentially, Peter, do you have any ideas if there are similar operations that essentially can abort something that is running?
Yeah, I mean, most sort of things in Kubernetes, I think the attempt is to have them be cancelable. But I would say I don't think that we should include this in the initial implementation, but try to design it in such a way that it could accommodate that in the future.
Yeah. And in case of timeout, so in the current proposal, we have a timeout for both checkpoint, restore. Should we, in the case of checkpoint, we can essentially discard the partial data that is currently created. And then in the case of restore, we essentially return an error message just to say that the restore has not been successful. Is that?
Yeah, that seems fun.
Okay.
I think
yeah.
one other thing I want to mention, this is going back to something Vicky mentioned a little bit earlier, but I just want to make clear, like, I think we have space to define new paradigms, and I think that we should not be afraid of that, even if it might make the KEP take longer. Like, I want to make sure that we are entertaining the idea of expanding. I think that this was about like pod status something. I forget exactly what made me think of this, but I just want to like reiterate, like, I don't want to massage an existing thing to make it kind of work. I want to, if we need to, I want to introduce something new to make it really work. So I just want to declare that as like a design principle that I'm thinking about in this process. And I yeah, don't want us to shy away from introducing something if it actually would materially answer, you know, the question correctly.
And in terms of timeline, what would be the next step for the KEP and getting reviews for that? And
we have to get this API question answered. So we have to come up with a handful of ideas on the next, like, you know, on possible approaches of, you know, having checkpointing and restoring in an API, and then we need to bring those options to SIG-Arch and to the API review team and try to get consensus about the approach. And I think we should do that as quickly as possible so that we have most chance to like actually get people to look at it and respond and work through it. So we have a chance of getting something in early 137.
Yeah. Okay. Thank you, Peter.
I like your ambition, Peter.
Thank you.
Are there any other questions for today? Yeah, I think we're almost at the end of the meeting anyway. So I think this is very helpful, and thank you everyone for your comments, questions, and feedback. And thank you, Peter, for essentially summarizing essentially what to do next. And yeah, I think this is very helpful, and I really appreciate it.
Great. Yeah. Thank you, everyone. See you next week.
You.